we're going to look at factors, and factors are basically pieces that make up numbers through multiplication. And it's really important to be able to break apart and put together numbers through multiplication, because this is how we deal with the algebra of numbers and how we deal with many operations, is understanding how we can break apart things into factors. So we're going to look at two different things. One of them is the greatest common factor, or factors are the pieces that we break apart to make other pieces, other numbers. So for example, if we want to break apart a number 10, we can break it up into 2 times 5. So 2 and 5 represent factors. Okay, so here we have 10 goes to 2 times 5, that's factoring. We're also going to look at least common multiples, and multiples are basically skip counting. So 2, 4, 6, 8, 10, 12. We are talking about multiples, and again, we're skip counting, meaning we're dealing with groups of things, and we're talking about multiplication. So we want to grow numbers through multiplication. So we need to recognize when we're dealing with factors and when we're dealing with multiples. So here we have a problem where we have 20 red poker chips and 24 blue poker chips. So this area in here, the red area, imagine arranging 20 red poker chips in here and 24 blue poker chips in here. And it needs to be arranged in a rectangular array. Okay, so we need to have them arranged in this way where they're all in a row. Okay, and they have to have the same number in each row. Okay, so what we want to do is we need to figure out how can we arrange these poker chips so that one side, the red side and the blue side, have the same number of chips in here. So we have the same number of rows in here and here. So there's a few different ways we can do this. And what we're looking for is the widest possible way we can arrange this. And so what we're looking for is a common number of rows, or a common edge length. And when we're talking about common edge lengths, we're really talking about a common factor. Okay? Because when we talk about area, we're talking about length times width. And when we talk about factors, we can talk about factors as a common edge length, or a common width in this case. So when we look at 20 and 24, what's the greatest common factor? Well, we can factor using factor pairs. We can see that 20 can be written as 1 times 20. Okay, we can see it as 2 times 10, 4 times 5. Okay, so those are all the factors of 20. And we can look at 24 and do the same thing and do this in pairs. This one's a little bit harder because there's a lot more factors involved in 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so they're just kind of rearrange this a little bit. So these all represent the same factors as well. So when we look at this, we can say, what is the common factor that both of them have? So that's one way to do it. So the answer, you probably have worked out already, the answer is 4. So we can arrange it in 4 rows of 5 here. We can do this in 4 rows of 6. Now some of you may have done this in a different way. You said, well, what's the biggest number that's divisible into both of those? And you could do some kind of divisibility testing. And we know that we're not going to divide this by 6. But we can divide this by 6. Okay, so we can't, that's not a common divisor. So in this case here, the common divisor is 4. We could have 2 as well. However, 2 is not the biggest one. So we have our greatest common factor represents if we can find them in pairs, okay, we can find them like this. We can think as the biggest divisor as well. One way we can do it is, another way we can do it, and this is a concise way of doing it, is looking at in terms of prime factors. So 20 is equal to 2 times 10. Okay, so 20 is equal to 2 times 2 times 5. That's equal to 20. 24 is equal to, well, we can do 4 times 6, 2 times 3, 2 times 2. So we can show that as 2 times 2 times 2 times 3 equals 24. And the factors are in common. To find the greatest common factor, we just group all the factors that match. And the two 2's match, so the biggest one is when we want to make it the biggest factor. We want to group them together. We end up with the greatest common factor of 4. What we really want to do as a model, though, is think of greatest common factor as the common side length. Okay, we have 2 sets here, and if we want to know what the greatest common factor is, we look for the common side length that allows us to show this in an array. So the lowest common multiples are when we grow numbers. So factors are when we break apart or fracture numbers. Multiples are when we grow numbers or do multiples, right? So when we have 2 tracks here, we have 2 sets of tracks. One's made from 9-foot long sections. Okay, so in here we have 9-foot long sections, so this is 9 and 9. And we have another set of tracks made from 12-foot sections, 12 and 12. And we want to be able to have them the ends of them line up. So what's going to happen here? Well, we can just kind of draw it out and see what happens. We get 9, 9, another 9 here. That's going to be 27, 36. And if we do 3 sets of 12, we get the 36 as well. Okay, so then we have at 36, we know that we have both tracks are in the same and start and end at the same point. Okay, so this is when we have, this is the lowest common multiple is going to be 36, and we know now that once we get the lowest common multiple, if we go another 36, we're going to end up with the same multiple. So we can kind of measure this out and do it. We can do it other ways as well. We can make lists. So one way is to make a list. So we can start with 9, 18, 27, 36, 45, 54, ... And we can just keep going with that list. We can make another list of 12, 12, 24, 36, 48, ... And we can see from our list that we have a common 36. That's the first time it's common. And we can note that if we keep on going, 63, 72, 81, we know that now that we have a common multiple, we know that at every 36, multiple of 36 now is going to match as well. Okay, so 36, if we double that, we go to 72, both those will match. And then we can go to 108, and both of them will match. So that's one way we do it. We can just list it out and see where the multiples are. We can also find lowest common multiples from the factors. Okay, now this is a bit more advanced, but this is more efficient as well. So when we look at 12, we can look at 12 as 2 times 2 times 3. And we can look at 9. 9 is equal to 3 times 3. And when we talk about multiples, we can use multipliers to find multiples. But we want to find the lowest common multiple. So if we just multiply this all together, 12 times 9 is 72. 12 times 9 is 108. We will get a common multiple, because if we multiply 12 by 9, that's a multiple of 12. If we multiply 9 by 12, we get a multiple of 9. So they are mutually multiples of each other. But we want the lowest common multiple, so we don't want to double up on multipliers that they have in common. So what ends up happening then is, what we can do is take one multiplier from each of these, so 2 times 2, and when we have a common multiple, we don't need to use it twice because we know it exists in both of them, so we just use it once and times 3 like that. And by eliminating the common multiplier, we don't over multiply, and so we end up with 2 times 2 times 3 times 3, and 36 represents our lowest common multiple, or LCM. So that's one way we can do it. Another strategy which uses basically the same principle is multiplying these two together. So 12 times 9 gives us 108, which is a common multiple. And if we want the lowest common multiple, we divide by the common factors. And we end up with our lowest common multiple using this process. Okay, so what that ends up doing is it finds the common multiple by using all the multipliers, and it finds the lowest common one by eliminating the one that is shared between them, so we're not over multiplying.